organized counting, and you return to Pascal's triangle. So when you're in grade 12 and you're doing the data management and probability course at some point, you're going to get into this organized counting and then utilizing Pascal's triangle. You're going to run into it actually on several occasions. The first time that you should have run into Pascal's triangle was most likely in grade 11 when you were doing binomial, okay, expansion. So that is basically when you're dealing with polynomials. So binomial is basically two terms, and then you are expanding them. I did a video on that in grade 11, so you can go back to it, okay, if you've forgotten it, although I will walk you through Pascal's triangle again in terms of a summary and some of the properties related to it, because you will need it in this organized counting course. So that original grade 11 video, I'll put up a link up above there. Now, in Pascal's triangle, so there are different ways of trying to approach and kind of memorize or remember that triangle. The main concept of it is that you're just going to be summing up the two items above you to get your new item. And I'll show you what I mean by that. Now, before I jump into that and creating that triangle, there's going to be three items here. So I'll talk about the triangle itself. I'll give you a general kind of formula, so what each term will be. I'll explain what the N and the R stands for, and it will relate back to something that you do in counting anyways, right, when you return to it. So there's a reason why there's an N and then an R. You're going to notice a pattern, okay, when you're going to be summing up your rows. Actually, each row that you take, you know, there's going to have a particular pattern. So this 2 to the power of N is going to make more sense to you in just a moment. And then there is one key item, so the triangular numbers that you have. Okay, so that is with regards to the third diagonal, and I'll show you what that means. Okay, and I'll give you just one example. And that's what we're going to cover in this video. So the triangle itself follows the following. So way back, Pascal, although I think someone, when I was reading, it was someone I think in China also discovered this. I'm sure maybe probably others have as well. It's just been now accredited to Pascal, especially in the Western world when we're studying this. So this triangle is done in the following way. So if you start at the top, I didn't do this in grade 11. I started with just row number 1. But if you start with the number 1, all right, and I'm going to call this basically row 0, okay? Pascal went about this as saying that if you now create and just go below it and you try to create two adjacent numbers. So I'm going to go, okay, this is going to be a 1 and then this is going to be a 1. And what we're going to be doing is we're going to be finding, okay, so this number right here is going to be the summation of the two numbers just above it, okay? So now there's only one number here, this one, and you can imagine if there was another one there, but there isn't. So if you add up those two numbers, you know, you'll get the 1 again. And now, okay, if you do the same thing and you try to find, okay, so this number, you would basically sum up the two just above it as well. Okay, and you're going to go 1 plus nothing is going to be 1. Now, if we continue this pattern, then what you're going to notice is that, okay, so you're going to get another 1 here because it's just adding up the 2 above. Okay, so this is, you know, adding up this plus that. Now, if I'm going to add up the next one, so this is going to be this plus that, then I'm going to get a 2. And then I'm going to get a 1, okay, because it's going to be this plus that, and of course the one on the right, there's nothing to add there. And you continue this pattern, and it's creating this triangle because we continuously have one more number as we're associating this through. So once again, so if you go now from here, okay, and you're adding up these two, you're going to get a 1, okay, and now you're going to be adding these two, you're going to get a 3. You're going to be adding these two, you're again going to get a 3, and then so on, so you're going to get a 1. Now I'm going to remove these arrows, all right? so that they're gone, so we don't have to worry about that. So that's something that you've seen in grade 11 in that video that I was referring to. And now, okay, so we started, so this would have been known as, so this right here is known as row 0. This right here is known as row number 1, okay, and this right here would be row number 2, and then so on. So this would be number 3, number 4, and then this continues. And you can create this triangle. I'll do one more for us. So 1, it's going to be 1 plus 3, which is that. Then it's going to be 6, 4, and 1, and it continues on. Okay, and then the rows just continue. So they start with 0, and then they continue 2, 3, 4. Okay. Now, typically, you know, you may not even see this row, okay, right here. So this might just start with like that, okay, with row number 1. But, you know, I'll leave this one in there, okay, just so that it does create a really nice triangle for us. Now, the rows themselves, so all of these that we see right here, okay, so they continue on, and basically, you know, you can get to the nth row, okay, so this would be the nth row. Now, each entry that we have also starts, okay, it's kind of interesting, okay, so that we can figure out each entry and then what that each entry is. So for instance, we knew, so right here, okay, what I did was this entry itself, so this is the term, right, that came from the addition of these two terms right here. Now, we identify these terms. Okay, so this one right there, this would be, okay, coming from the third row. So we would put a 3, okay, comma, and it is, and now we're starting, and now we count them up. Again, we start to count from 0. So this is item number 0. This is item, okay, number 1. Okay, this one right here. So this would have been, so let me just maybe remove this. Okay, I'll put it like this, 3, 0, because it's the third row, the 0th item, and then it goes 1. This would be 3, 2, and then this would be 3, 3. Okay, and now you can label all of those items. Okay, and so this one, for example, would have been, this is 4th row, this is starting from 0, 4th row, and then it's 1, 4th, 2, 4th, 3, and then 4, 4. Okay, so just so we can identify. So you can find out any term, so T, N, okay, and then the actual, okay, item itself. And you'll sometimes see it as defined as the T, N, comma, R, where N stands for the row itself, and then R stands just for the item in the list, okay, that you have. And it's starting from 0, 1, 2, 3, okay, and then it goes up to, okay, N, which would have been the row itself. So now, why did I put this in here? Because you don't want to, by brute force, just continuously be creating these kind of rows one by one to eventually get there. Like, what if you wanted the 15th row? Right? Are you going to create 15 row and just keep adding up? You could, and that's what we did in grade 11, because we were just kind of finding out we needed for that binomial expansion, okay, within polynomials. But here, in terms of the counting, we do want to have a general sense of how do we create this item. And it turns out that if you do want to know any term, okay, so any term in the nth row and then the R item in that row, it is simply just equal to, we know, the 2 above it. And the 2 above it, it would be, well, it's 1 row up. So this would have been n minus 1, okay? And 1 to the left and then 1 to the right, okay? So this would have been R minus 1, so that's to the left, okay? Plus the other term, which is 1 row above, and this would have been just R. And you can see that happening, okay? So notice if I would take, for instance, this term, which is 4, 2, okay? It is the addition of this and this, right? Which would have been, so 4th, okay? So this was the 4th row, so that's 4. So now if you go above it, it's the third row. And then it's the 1 minus, so it's 2 minus 1, which is the 1. Okay, and then the 2 itself. So it would have been those 2 particular items added together. So that is, in general, what the formula is for Pascal's triangle if you wanted to find any of the actual terms. Now, this doesn't necessarily mean that you can, by magic, try to get them, although you will be able to use organized counting, okay, as you go through the chapters, okay, to find these particular terms very easily. Okay, you're gonna have to wait a little bit, okay, and once that video is up, okay, I'll redo this triangle so you'll see this again. Okay, for now, that's what we're going to know it as. So that's Pascal's triangle. Okay, this is the actual formula that you have. And now what's interesting about each of the sums of the rows as you're going from each row, if you're going to be adding all the items in each of the rows, then you will notice that, for instance, if you're going to add up all of this, and obviously the answer in here is just 1 because there's just one item. Okay, if you go to row number 1, 1 plus 1, this is going to be 2. If you go to row number 2, it's going to be 1 plus 2 plus 1, which is 4. And then, so let me bring this, so this was 3, right? So now if you add all of this up, you'll notice that the answer is 8. If you add up the next set, you notice that it's going to be 16 and so on. And what these equal is that for every row, the sum is nothing else but 2, notice, to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. So the summation in general is that the sum of each row is equal to 2 to the exponent of the row itself. So to the nth row. And that you can find out very quickly if somebody asks you. So that is a nice pattern that this Pascal's triangle has. Now there is an additional kind of pattern that we go through and that we notice. And this is kind of the triangular numbers. And what this comes from is the following. So if we were creating a pattern, so this is just an application, I guess, of this, and it deals with triangular numbers. So if you were starting off, let's say, and you had, I don't know, some coins maybe, okay? So you have a coin, right? So this is your first one, okay? So you have only one coin. Now imagine that you try to create these coins. Maybe what I'll do is, let me do the following. I'm gonna copy this, okay, and then we're gonna paste it up. So now what I'm gonna do is, okay, what if I do them side by side? And, you know, now I basically create a little triangle, right? So I'll just put one more coin. So I have one coin, now I have, so this is one coin, it's creating this triangle. Now this is 2 coins. Now if I take this, okay, I copy it, paste it. All right, so if I put this above and then I try 2, and now create these circles again, I'm gonna copy and paste, so just so that it's easier for me, and then copy, okay, and paste. All right, so now I have this. So I think you get the gist. Now what you notice is that you have 6 items here, right? So we had 1, sorry, this is a blunder. We had 3 items, then we have 6 items, okay? And now you can continue this pattern over and over. So if I would duplicate this, all right, put it right above, and then you will notice that obviously, I'm gonna just to save us time, you know, you would get 4 right here. So you'd be adding an additional 4, so this would have been 10 items, and you would have continued this. This is called kind of triangular numbers as you make them bigger and bigger. And what you notice is that if you follow the patterns within your Pascal's triangle, you'll notice that these triangular numbers, okay, or these coins that we're putting up, is going to be nothing else but just the third diagonal within your Pascal's triangle. So I'm going to do one more, okay, item within Pascal's triangle here, just so that you can see it, and then I'll point out to you that third diagonal. So this would have been 1, this is 5, this is 10, this is 10, this is 5, this is 1, okay, and this is what I mean by the third diagonal. So right here, if you go in this pattern like this, okay, then what you are noticing is that 1, 3, 6, 10, and of course continued on. So 1, 3, 6, 10, it's nothing else but the numbers from that Pascal's triangle. So that's what you could find, so you can actually tell, okay, what is the next number that you've actually need. So the next one, okay, within here is going to be 15, right? And then it's going to be 21, okay, and so on, because you can just keep pounding these in, okay? So that's something that I wanted to introduce you to in terms of counting. There are many other applications that you are asked with this Pascal's triangle when you're doing your counting, but I think that this is a good, okay, introduction to bring you back what Pascal's triangle is. It's relatively simple once you see the concept, and then there are some patterns that you associate. Now, trying to remember, you know, this particular formula within here, it's not always the easiest, especially if you're not doing it on a continuous basis, but you will find the N and the R useful, right, a little bit later on to try to identify any items that you have, and then we'll come back to that binomial expansion as well, so that you don't have to create these triangles at all. You're going to be able to see, okay, how each item in Pascal's triangle actually works. So we'll do that as well a little bit later on. Okay, thanks for watching. I hope to see you in another video. Bye, everybody.